Welcome to the Entura Effect, the podcast diving into the core details of managing and designing energy and water projects worldwide. Join us as we unpack the expertise and innovation at Entura, shaping a sustainable energy future. Hello and welcome to our new series of podcasts, The Entura Effect, where we'll explore the projects that we work on, their effects on the communities that we live in and our world in general. Today we're going to be talking to Pradipta Swain, our Specialist Engineer from our India office. He's been working on a project in the Himalayas called Kutehr Hydropower Project, 240 megawatt hydro project. The role that we're going to play on this project is Lenses Engineer, where we assist the financing of the project through providing engineering advice on the progress and risk management of the project. So Pradipta, hello and welcome to the Entura Effect.
Hello.
You're here to talk to us about the Kutehr hydropower scheme that you've been working on for the last 5 or 6 years. Maybe tell us a little bit about the scheme.
Thank you. Thank you, Donald. So Kutehr, it is... We have, I can say, but I have been involved with this project for the last, 10 years. And it is one of the highest barrages in India as per my knowledge. And it's a 240 megawatt project having 3 numbers of Francis turbine. And the length of the headrest tunnel is around 12 kilometer or something like that.
So Pradipta, here we've got a picture of the barrage. Maybe talk us through the key elements that we can see here.
Yeah, as you can see, it is the barrage we are looking towards upstream, standing on the downstream side. And you say the 3 gates to my left, you can see if we are looking towards the upstream, you can see 3 gates are closed. And 1 gate is open to allow the flow of water, and the rightmost is basically for the maintenance purpose, for the movement. This picture was taken you can say 5 months back, so that's why it was still under construction, but now it is almost completed.
So that's maybe an opportunity for us to have a look in a little bit more detail at the barrage itself.
In this barrage, you can see at the top we have gate operation chambers. You can see the hoisting arrangement. Those are basically operated from this house, and each gate has 1 operation chamber. And one thing you cannot see in this drawing is, in this picture, is a fish ladder. There is a fish ladder on the right bank of the river. So it is basically to allow the fish from the downstream to go upstream during the season. I don't know exactly what is the season, but it is there. It's the environmental requirement. And also, in addition to the fish ladder, we have there a water release arrangement. We have a valve. So as per the guidelines, as per the requirement of the guidelines, the required water is required to be discharged to the downstream.
Okay. Yeah. So under normal operations, all of the gates would be closed, and the valve would be the way that the water flows down into the river.
Yeah, that is the requirement. As a hydro project engineer, we like it to go smoothly and complete within schedule, but sometimes what happens, the report says that they have not done that much of physical progress, but financially they need more money, and as a lenders engineer we doesn't allow them. So there are many times we have friction between lender, client, and we as Entura, but we as Enturians, we don't allow our principle to go haywire. So we stick to our principle at some time, not sometime, at twice I have rejected uh, their application or their request for more money, and it was a lot of friction. At one point of time, even clients say, "No, it must be your ego." But however, after that, they know that Entura has a good principle, and they will not devolve from their direction. So after that, there was a good relation between among us, like lender, client, and we, as well as the contractor. And even the prediction we have given them, like initially tell them that there will be a 6 months delay, and it was true. Then again, after 2 years of commission, 2 years of construction or 3 years of construction, again we tell them that there will be another 3 to 4 months of delay, and it was found to be correct.
And talk us through the new old rock concept.
New rock means they say the Himalayan is not a old one; it's a new rock formation, and because of that, because of that, there is chances of sliding, falling of rocks, and sometimes along the road you will find patches of overburden material between the two rock mass. So those things generally fall on the roads, and they are having a huge destruction to the even peoples also. But from the project perspective, that road blocks for long times.
Mm-hmm. And this is a pretty common thing to happen in projects in this area.
Yeah, it's a very common thing in the projects in the northern side of India, which are likely, which are on the Himalayan zone, you can say. Yeah.
Okay. Maybe going back to talk about that tension in the project team between the lender, the owner, our role as lender's engineer. Presumably there was an owner's engineer, and then there's a constructor. Just talk us through the dynamics of that, perhaps around a particular example.
Yeah, actually, the client is okay. He has given the work to one consultant. He does all the design works, and I don't think they have any owner's engineer, but because they have plenty of engineer, they do owner's engineer by themselves. And one resident engineer is posted there, but he is from the consultant side. Uh, Except those two, the consultant and the resident engineer, no other engineers are there for to look after the design works or other things. Contractor in India are generally, they know very well the design aspects to some extent, and for that I think if anything wrong is there in the design consultant's drawing or something, they just send them back or request for a modification, something like that. But we, as a lenders engineer, we don't have any say on the design aspects. Only thing we see is what is the progress going on at the site, and what is the financial outlay during that quarter. So we don't have any say, because otherwise it's not our scope, basically. Yeah.
So our scope is more around validating the progress.
Yes.
And how do we go about doing that?
Yes. The progress actually is a very you cannot say how much progress has been done, but we have done some basic calculations, like we have a list of quantities in our tender document, right? So suppose you could talk about the barrage. So it is, suppose, 1 million meter cube or half a million meter cube of concrete, and they say that we have done 250,000 of concreting. So we can say, okay, you are 50% completed in that way. But you can say the hydromechanical works, So we have given them a sheet, a format, how to submit us the progress details. So they every quarterly they fill it those things and send it to us. So we use those Excel sheets and their reports to finalize the quarterly report. So we have made a, actually basically you can say we made a systematic way so that we can provide the quarterly report to the lender in time, so that the disbursement is in time, because otherwise without disbursement the project will suffer. Yeah.
Sure. And as part of those quarterly reviews, you've had to do site inspections?
Of course, we do the site inspection, and the site is at a good location. So we have to take a flight from Delhi to Amritsar. Amritsar is almost at the border of India and Pakistan, and then we take a taxi to the site. It takes around 6 hours.
It's a long taxi ride, isn't it?
It's a long drive. 6 hours is okay, for fine with us.
Okay.
Uh,
Right. And so, and then those site inspections look at the project from end to end?
Yeah. We start from the barrage, the upstream-most structure, the barrage or dam, you can say, and up to halfway, just finished, and they do the lunch there in their establishment. They have mess. Mess means they have a kitchen that caters to all the employees there. So we generally take lunch there, and then after lunch then we go to the downstream portion of the project, like Powerhouse, Surshaft, Sur Chamber, and all those things.
So, Pradipta, our role on this project was lender's engineer. Maybe you can talk us through the value that we bring to the lender as we moved through the project.
Yeah. So, if you think about the project in whole aspects, so it is the very important that the project gets the money right at the right time, so that the construction progress goes on without any obstacle. But at the same time, as we are working for the lender, as a lender's engineer, we have to guide the lender in such a way that at no time the financial aspects are distorted, or client says something which is out of way and it is not matching with properly with the financial outlay. Then at some point of time, it is, I mean, there are stories in the past that big companies, they get bankrupt within no time. So we protect the lenders from those mishaps, and you can say. So with our values, with our principles, we have tried a lot. We have tried it, not a lot, but we have tried to protect the lender from getting into those type of things. So I think we have engaged with this lender previously, and maybe because they have the faith on us, so that's why this second assignment come to us without any problem. Yeah.
Yeah. So you talk us through that relationship between us and the lender. What do you think the key aspects of that relationship are?
Yeah, the key aspect is the faith the lender has with us. Initially, they thought of, like other consultancies, we are also one of them. But after going through, after interaction during meetings, subsequently, they gradually know that, no, we are something different, and we really, protect them from any bad business, or like, anything which will be hamper their financial issues, which will happen there, which will misuse their finance. So that's the reason, and gradually, in due course, they don't have any questions regarding our advice, which says that they have gradually improved the relation and they have improved the faith on us. Yeah.
And that's important, isn't it? Because India's got a massive challenge ahead of it, like many countries, to get on the renewable energy road, if you like. A massive 500 gigawatt target by 2030, of which this is a very small part. But for that 500 gigawatt project to be met, we're going to need lots of people like this bank being willing to lend money to facilitate projects that are very complex, like this project. So it's really important for that trust to build over time, and the familiarity of these lending institutions with these projects and an understanding of the risks and which risks are manageable and which risks are not. So maybe talk us through some of the key risks on this project and how you were able to talk to the lender about how the contractor was managing those risks.
Yeah. Initially, the project was, when somebody sees the project, it in general, all the underground structures, construction of all the underground structure is a risk in the Himalayan region. So during our quarterly visit, we focus on the underground excavation, how they have progressed, how they are, doing the construction work in the bad zone, like bad geology. So all these things we just mention in our report and put it in a risk. Not only the underground construction, also we look after the approvals. They should have approvals in time, because in the absence of approvals, they may not do the construction work. So in addition to geological, the underground excavation and the existing approvals they have, we just go through those things and let lender know how much risk remains. So once the tunnel is excavated, you can say 50% of the underground excavation risk in underground excavation is completed. So that's why gradually we educate the lender, because the lender doesn't have a knowledge of the hydro project. So we educate gradually them how the project works and what are the risks. After you say one of the edit, edit number 6, it was really a high risk area because of the geological uncertainty at that location particularly, and most of the slides also took place in that area. The main problem was that below that edit 6 there is another power station, not there, but another power station is there. So any rolling of big boulders may destroy their power station. So it was a very high risk area, and that area took the last, it started the last, and it will likely to be commissioned the last, because through that edit they have to excavate the last portion of the headrest tunnel, the search shaft and the valve chamber. So it was a very high risk zone, and we have been telling the lender that this is the high risk zone, and it will be the critical activity in the whole project, and it found to be true at the last.
Maybe this is an opportunity for us to have a look at the project in more detail on the map. So now we're going to look at the map of the aqueduct and just show people how it moves from mountain to mountain, just so that we've got a visual cue. Apologies to people who are listening to the podcast. So you can really see the way that the pipe sort of disappears into the mountain on each side of the ravine, and incredibly steep access. So did they build access tracks or to get people up into the tunnels, or you talked about adits? How did that work?
Yeah, actually, it's a deep gorge and with the steep banks, so it is very difficult for even the native peoples or the inhabitants of that area to reach to that portal location and do the preliminary blasting and making a platform for the people to stand at the location of the portal. It's very difficult. So what they have done is they have excavated the edit or the access tunnel to the headrest tunnel, and they excavated the headrest tunnel portion between the edit and the gorge on both side of the gorge, both side of the stream, and they reach the portal location through that only. So whatever they have done is only through the headrest tunnel and the access tunnel only. They have never tried to reach to the portal from the outer side because it's very steep. Yeah.
So Pradipta, maybe you can talk us through the overall scheme and how the water moves through that scheme.
Okay. So we have a barrage at the upstream end of the project. So that is a gated one and has 5 bays, and it is one of the highest barrages in the India, I remember. And once it is the gates are closed, the water will be diverted through the intake. There are 2 intakes, and the 2 intake tunnels, they feed to 2 desilting chambers. Then after it is desilted, then the silt free water is entered into the headrest tunnel through 2 connecting tunnels. And of course, below the desilting chamber, we have silt flushing tunnels, 2 silt flushing tunnels, and each silt flushing tunnel is connected to the main silt flushing tunnel to take out the silted water to the Ravi River. And these silt flushing tunnels are also equipped with gates. Similarly, the desilting chamber, in the desilting chamber, downstream of the desilting chamber, we have the gates. It's basically for the maintenance purpose. So if one desilting chamber is under maintenance, the other can be used to carry water to the powerhouse. So once the flow reaches the headrest tunnel, it is a underground and lined tunnel. So the whole project is from the upstream end to downstream end will be around 14 to 15 kilometer long.
Wow.
Yeah.
Yeah. And how much water flows at full power?
It's full power. I remember it will be around 50 to 60 cubic meter cube per second.
Right.
Yeah.
So
And,
that's
yeah,
60 tons of water a second.
meter cube per second. Yeah. 60 ton. Yeah.
Yeah.
And the head is around 300 plus meter, something like that.
Yeah, wow. So 300 metres of head between the barrage and the powerhouse, but the barrage is only how high?
Barrage is around 22, say 23 meter high.
Now talk us through the silt. And you talked about quite a detailed arrangement to try and get the silt out of the water. That's a real feature of hydropower in this area, isn't it?
Right. Silt, actually, in Himalayan region, you will find a lot of silt. So some river carry a lot of sand, a lot of silt. Even during the rainy season, it goes above 5,000 ppm, parts per million or milligram per liter, you can say. So once, if it is within 2,000 or 2,500, we use the desilting basin to take out the silt. But if it crosses 5,000, generally people avoid to operate the powerhouse. So during those period, during the flood, the powerhouse remain closed. Otherwise, there will be a lot of wear and tear of the turbines. So we just avoid that.
Yeah, it's very abrasive, isn't it, on the turbines
Yeah,
and on the other equipment around the turbines.
right.
Yeah. And so then the silt gets deposited into the Ravi River in this case.
Yeah.
How is the flow in the Ravi River regulated?
We in the barrage we have the radial gates, the 5 bays. So we have 5 radial gates. So it is the hydromechanical experts, they say that radial gate is the best for the silt laden water to pass through, because vertical gates likely to be jammed or something during the flood time. I mean, while opening it may not open. So but radial gates are good, so that's why provided, although it is costly. Yeah.
Under what circumstances would the gates be opened?
Yeah, it depends upon the how much flood is coming in the river. So usually these gates are closed to maintain the water in the reservoir at full reservoir level or full supply level for the generation purpose. And during the rainy season, uh, I don't know exactly how they will going to operate, but in general, what happens during the rainy season, it is likely that it should be operated at minimum drawdown level, or you can say minimum water level, because the incoming flood can be, accommodated within the gap between the FRL MDDL without, without flooding or without any issues with gates and other things. Yeah.
And when the barrage is at full supply level, how far back up the river does the flooding occur?
Yeah, we there is an upstream project also that is called the Bajoli Holi. So the reservoir extends up to the tail race of the Bajoli Holi. So it is a basically cascade project. So the upstream most is Bajoli Holi, and again the next downstream is the Kutehr. So there are a lot of projects all along the Ravi River.
So this is a picture of the barrage while it was constructed. Now it's complete. Is that right?
Yeah, it's completed, and it is likely to commission within next few months. So it is almost completed. Now the gates are closed and the reservoir are almost filled up to the, up to certain level. Not, I cannot say whether it is FRL or MDDL, but it has completed. Yeah.
Okay. So from the barrage, the water goes through the tunnels down to the powerhouse. Maybe if you could talk us through the layout of the powerhouse.
Yeah, it's the Powerhouse complex. You can say it consists of a Powerhouse cabin, a transformer cabin, a collection chamber, the downstream conveyance system, including the 3 unit penstocks, 3 unit tailless tunnels. Then from the search chamber we have 1 tailless tunnel. So all these are located in one big rock mass, and in addition to all these caverns we have main access tunnel which is used to access the Powerhouse cavern. Then there are some edits like construction edits, of course, from the main access tunnel to the bottom of the pressure tunnel, and one goes to the search chamber, downstream search chamber. So there are a lot of edits, caverns within that mass, and all are, they have been designed to be stable by putting rock bolts, short kits, and other rock support system. So these have been oriented according to the requirement of the geologist, or according to the rock mass. They have been studied in the initial stages and found to be good. And the Powerhouse houses 3 Francis turbines. Then you go to the transformer cavern. I think all the transformer are single phase transformer. I have already discussed that the road condition is very poor up to the site. So they have suggested for the single phase transformer, which are of smaller size and smaller weight. And then the GIS is also there in the transformer cabin. At the bottom they have put the transformers, and there is a one floor. On the floor they have put the GIS, because GIS is a required. They don't want to put a AIS, which requires a lot more space, and which is generally not available in that type of terrain. And then after the transformer cabin, you have the surge chamber at the downstream of transformer cabin, and from the downstream surge chamber, you have the main tailless tunnel taking the water out to the Ravi River. Yeah.
Very good. And so just in terms of the physical dimensions of the powerhouse, how big is the cabin?
Yes. It's a medium height, you can say around, I don't remember, but it will be around 50-meter height. The transformer cabin will be around 29 meter, and the surge chamber will be somewhat between 40 meter, somewhat between 40 meter. Yeah.
Right. And how far underground is it?
So generally looking at the center line of the Powerhouse cabin, it will be around 150 meter below the surface.
Okay.
Yeah.
Right. So not a long way down in the grand scheme of things, but yeah, still a lot of rock above your head when you're in the cabin.
Yeah, because generally, you see, the 50-meter height means we need at least 100 meter of rock cover at least. So 150 meter says that even if you have some 10 to 20 meter of overburden, still you have a good rock cover above the Powerhouse cabin.
So Pradipta, this project represents a fairly large chunk of your overall career. What's driven you to maintain the rage on this project? What excites you about it?
The main thing of the project is, it includes each and every component of a hydro project that should happen. And I cannot say that it is a very big project, but in a medium scale, it includes each and everything. And as I am associated with this project from the beginning, so I am very much interested in this project, and it excites me really, because it is going to commission in a few months. So that is also a great excitement to me. And then it's a big project. I think it will be very good managed even after the commission, during operation also.
And will you get to be part of the witnessing of the commissioning or the opening of the scheme or anything like that?
Yeah, if the client says that Entura become a participant in the commissioning of the project, then it's okay. Otherwise, as a assignment, will be there for the commissioning of this project.
Right.
Yeah.
Yeah. And so when the water flows and the power starts to leave the power station, how will you feel?
It's really excitement. I can't say anything, but I'm really happy. I'll be really happy. Yeah.
Well, Pradipta, that's been a fantastic insight into our work as Landslides engineer on the Kutehr hydropower project. Thanks for your time today. Thank you for tuning in to the Entura Effect. We hope you've enjoyed exploring the details of energy and water projects with Entura's experts. Subscribe, rate and review to stay connected, and visit entura.com.au or follow us on LinkedIn and Facebook for more. Until next time, this is Donald Vaughan signing off.